So let's try the other part. And again, we want to attack this systematically and go back and redo whichever of the steps we need to go back and redo. Okay, I think we might have had some trouble with that part. So now it looked like you did go back and redraw the picture, so that's good. Now we need to extend this back further to a time when they were starting from rest at 0 meters per second. And so we want to relabel our initial and our final points. Here's our new initial point. And what should our final point be? Well, probably the best thing to choose as the final point is this point over here, because they want to go to the end of the 140 meter distance. But I am going to change this initial point. Maybe we should erase these times now, or you can still keep them. If you keep this at 0 seconds, then this would be a negative time, because it's before the initial time. That's not too crucial here. Now we have to ask which of these numbers still holds. So for example, does this time still hold? No. It looked to me looking over your shoulders that most of you were still using the 3.6 seconds. Maybe
I used it to get the acceleration.
Ah, okay, my mistake. Good. All right, well then maybe then you were doing good. Excellent. Okay, my mistake. So you're right. So this problem turned out to be more similar to the previous one than I expected. Okay, good. So that's absolutely right. We can't really bring down this distance or this initial velocity. We can bring down the final velocity.
But we have the initial velocity is 0.
Excellent.
It tells us for
Right. All right. And what's the question asking us for?
the distance.
Right. And once again, how do we know that the acceleration is going to be the same? Well, the problem told us it's constant acceleration. So again, we should figure out this acceleration and plug it in here. Okay, good. So for this, we have v final equals v initial plus at. So that would be 53 equals 24 plus 78 plus the acceleration.
Times 3.6.
So solving that algebraically, you would get
7.84.
7.84, that's what everyone got? Did that come out positive or negative?
Positive.
And is that what we would expect?
Yes.
Yeah, because this is a problem where we're speeding up. So we have 7.84 meters per second squared. That number we can bring down. 7.84 meters per second squared. All right, and now we have three variables, so we pick the equation that's missing the time again. So our V initial would be 0. That'll simplify things. V final is 53 divided by 2. Oh, I picked the wrong equation, didn't I? That's not the one that's missing the time. So let's try again. That would be V final squared, initial squared plus 2a. This is the equation that's missing the time. V final is 53. The initial is 0. What did you get as your answer here?
179.145 meters.
All right, 179 meters. Does that come out positive or negative?
Positive.
Yeah, is that what we would expect?
Yes.
Yeah, and we should have made a prediction to start with. What could we have already predicted on this problem?
That it would have to be more than 140.
And it did come out to be more than 140. Very good. Okay. All right, well, that turned out to be more similar than the previous one than I thought. All right, but anyway, the key thing here is that we're seeing how to do these multi-part kinematics problems. So for the new part, redraw your sketch, redraw your set of 5 variables if necessary, and ask which of the numbers you can carry down and which ones you can't.